Okay, so welcome to my presentation about graphics drivers and Wine for modern gaming. My name is Stefan Dosinger, I'm with CodeWeavers, and yeah, you have my email address if you want to contact me. So basically the outline, I'm going to give a short overview about the GPUs we care about, their capabilities, a bit about the reliability of the driver and what I mean by that. And well, then further on it's mostly about performance, and finally some conclusions and what we can do to improve things. So basically, which GPUs do we have? They're usually, well, you can classify them by their vendor, and usually they are classified for the better or worse by the direct 3D generation they belong to. You could argue if it's a good idea or not, but that's usually how it happens in gaming, the gaming press, and when games talk about graphics cards. So nowadays, you have Direct3D 10 and 11, which I've grouped together for now because Wine does not have a Direct3D 10 or 11 implementation yet, so we don't care about their differences. You have Direct3D 9. 8, and I've grouped everything below 7 because it doesn't really matter too much as well. So basically, on the Nvidia side, everything new, a GeForce 8 or newer is a Direct3D 10 GPU. On the AMD side, it's a the Radeon HD cards. And on the Intel side, I'm not quite sure about Intel, but Intel, I think i9-65, or also called GMA X3100, support Direct3D 10. For older cards, you have the GeForce 5 to 7, which mostly support Direct3D 9 to various extents. GeForce 3 and 4 are DirectX 8. And similar on the AMD side, which at that point was still called ATI. We have some estimation about the market share of those GPUs. According to the Steam hardware survey, about 50% of Windows users use Nvidia cards, 44% AMD, and Intel has a comparably tiny market share among gamers. But you have to watch out. There are other statistics which are about GPU sales and chip sales, and Intel clearly dominates the amount of chips sold. And you don't know if they actually use them when they have the onboard chips on mainboards, but there are clearly more than 10% Intel GPUs used. And I think the truth for Wine is closer to that one here. So we do care about Intel, even if gamers probably don't use them that much. And most GPUs used these days are Direct3D 10 capable, according to the Steam hardware survey. Which begs the question, which GPUs does Wine care about? And I've answered that we care about Direct3D 9 GPUs and 10 GPUs definitely. You have to keep in mind that's not just about gaming. If you're playing a video, it's probably using Direct3D. If you are using Internet Explorer and the Flash plugin comes up, then it's using DirectDraw. So you want to work on old hardware as well, just so to allow people to use whatever websites they have to use Internet Explorer for. We probably don't care that much anymore about DirectX 8 GPUs, but we have a lot of code dedicated to them using vendor-specific OpenGL extensions. And at Wine, we generally have a policy of not killing code that serves a purpose and works. I'm not really caring that much about Direct3D 7 GPUs. We aren't actively breaking support for them, so we are using OpenGL, which provides an abstraction layer for that. But if some bug report comes around, if it's a simple bug, then I would probably fix it, but I'm not going to turn the code upside down for 15 years old hardware. All right, so driver features, this is pretty quick to sum up. As far as Wine is concerned, the big features we need are there. You can argue about some small extensions, sRGB, color switching, whatever, but basically Wine can work without them, without killing major features. There are some OpenGL 3 and 4 features missing on the open source drivers, but since Wine lacks a Directory 10 implementation, well, it's work in progress, but it's still not there. We don't really care about OpenGL 3 that much. One thing to point out is that while OS X supports, I think, OpenGL 3, maybe 4, many features are missing in legacy contexts, which Wine at the moment still has to use for Direct3D. So we are missing some features there, like uniform buffer objects or HRB map buffer range. But I guess nobody here is an OS X developer, so whom am I complaining to?
To the right people.
Yeah, it's not the right people to complain about Apple's drivers. So how well do the drivers work? So there are a few criteria. First is, if you advertise a feature, does it work? And that's mostly aimed at Apple as well. Don't knowingly over-advertise your graphic cards features. So I'm going to get to that. And also, if I'm rendering something, does the system crash? Does the application randomly crash? Wine sometimes uses some corner cases, and every now and then they are poorly handled, like rendering to the same frame buffer object from different contexts, things like that. Are there software fallbacks? Like if features are over-advertised, most of the time the driver implements them, but falls back to software, and your performance just tanks and it's unusable. And last but not least, if there is a problem, can we as Wine developers get some access to the developers to say, hey, please fix this? So basically, features work pretty much everywhere, except, well, on OS X, DirectX 9 GPUs are advertised with OpenGL 3 features. So we have a database in Wine where we detect the GPU and say, okay, OpenGL implementation, you tell us you have this many uniforms. No, we know we don't have 4096. You have only 256. Nvidia basically is okay, except Nvidia on Linux is basically okay, except that getting in contact with developers is kind of a mixed thing. Sometimes they reply after a few hours, and sometimes problems just go unnoticed and never fixed. The AMD binary driver, well, it's crashing every now and then. It's got a lot better in the past years. Sometimes they get some corner cases wrong. I think they fixed 2 bug reports of mine a while ago. On Mesa, the features that are advertised are usually there as well. I can't think of an example now where Mesa advertises something and then falls back to software. I haven't seen that many system crashes, application crashes that lately. And usually corner cases work, or if they don't, then we can fix it ourselves. Which also means developer responsiveness is Mesa is good, because usually we get a reply pretty quickly to bug reports. And even if we don't, we can just grab the source code and look at it ourselves and find out what's going wrong. And once we send a patch, then we get a reply. In the case of all of those vendors, you have to put in an effort to get a bug fixed. It's not enough to just say, oh, something doesn't look quite right here, please fix it. Nobody's going to respond to that. But if we say, in this situation, blah, blah, blah goes wrong, then Mesa is the best. And, well, Apple, no. Well, the main criticism I have here, to put something specific, they have a bug tracker. You can't search it. You can't look at bug reports others filed. So if you want to figure out if somebody had this problem, you can't do that. If you file a bug report, they are not replying to that until they fix it. So you file a bug report, and 12 months later say, hey, you may want to retest that. We fixed it. Oh, great. Thanks for replying. And if somebody else already filed that bug report, then yours is closed as duplicate, but you can't look at the other bug report. You can ask every now and then, did the original bug report change? And then there is no reply, and you can understand it as no, but well, yeah. Okay, now let's get to performance, where I can actually present some data. But first, well, benchmarking is difficult. Basically, you have the CPU, which runs the games where the driver is running. The driver generates commands, sends them through some bus, usually PCIe, to the GPU, which executes those commands, and the GPU runs the shaders the game provides. And your performance problems can be in any of those components. If one of them is slow, it drags the entire thing down. So, which is probably not that important if you just want to present some graphs, but if you want to fix problems, you have to find out where they are. And to make things even worse, if you, let's say, run Half-Life 2 on Wine, and it runs at 100 frames per second, and you run it on Windows, and it runs at 300 frames per second, there are a lot of things that change. There are a lot of software components that a bug can be. The problem can be in Wine, it can be in the direct-to-D parts of Wine, in the non-direct-to-D parts of Wine, it can be in a driver, it can be in a Linux kernel, it could be hacks in a Windows driver. You really don't know, and it's a pain to find out, but luckily some games have different configuration we can use. Like some games have a direct-to-D renderer for Windows and an OpenShell renderer, and we can use those to compare how OpenGL compares to direct-to-D on Windows. Specifically, I've used Unigine Heaven benchmark and Unreal Tournament 2004 for that. The data is rather thin on that, but we really don't care too much about the difference between that because no open source component is involved. So if it's different, we can't fix it. It's just interesting to know how, let's say, the native Team Fortress 2 port compares to Windows Team Fortress 2, which is using direct-to-D on Windows and OpenChill on Linux. So you kind of want to know the intermediate step of OpenShell on Windows, just to understand the data better. If you then go to the Linux side, in every case, the Linux driver becomes involved, and the difference between the Windows and Linux driver matters. If you're running a Linux native application, you have the compiler, which influences things. Especially Linux native binaries are often 64-bit and the Windows binaries are 32-bit. I fooled myself on running the benchmarks and got a 10% better performance in Linux compared to running the Windows application in Wine, and then figured out, well, actually no, it's just 64-bit versus 32-bit. In the same way, if you run the Windows application, the Windows version of the game in Wine, then the game itself is not different, but the driver still changes, and Wine potentially influences results. And the same thing if you go from a Linux native version to running an OpenShell game in Wine. Whatever you do, you always have 3 or 4 more potential factors that influence your results, and you can never cut it down to just one difference. It's you can try to get a few sets of combinations and then deduce some information from that, but that's tricky. And if you go from Windows direct-to-D to a direct-to-D application running in Wine, well then pretty much everything causes things. So basically what I've done with the benchmarks, I didn't use any tweaks. I used some common sense or well-known things like getting rid of background processes on Windows using the S3TC libraries, but otherwise everything was left in a default state to get results which are realistic for users who don't know how to configure Wine or configure their drivers. Alright, so I have benchmarks for one Nvidia GPU, one AMD GPU, and one Intel GPU. The Nvidia one was in this laptop, which has a Core 2 Duo GPU. I was running Windows 7, and well, Gen 2 is kind of undefined test parameter. If anybody wants to reproduce the benchmarks, better get in contact with me per email. I don't have the time to discuss all game settings here. And I hope to test OS X and Nouveau, but I started preparing for that 4 weeks ago and ran out of time. So, well, the results. Basically, I have normalized the Windows Direct2D performance to 100%, and the other results are relative to that. And I've set up a CPU limited setup where I kept the resolution to the minimum, usually 640 x 480, and a GPU limited setup, which with the maximum resolution and sometimes anti-aliasing enabled. So basically what the results were on Nvidia is that OpenGL on Windows is slightly slower. Well, I just have to accept it. The Linux driver usually beats its Windows counterpart. So it's like 20 to 30% faster if you then, since I compare to the Windows Shell driver, which is lower than DirectX, it's well still slightly above what the DirectX driver is doing, which is just fine. So we have no reason from a performance point of view to compare about the Nvidia binary driver. Wine's Direct2D performance sucks. It's our fault. It's not the driver's fault in this case. And in the CPU limited case, the results are pretty similar across games. So the standard deviation, I didn't calculate it, but it was probably 10%, which is still noticeable, but it's not quite as bad as in the GPU limited configuration. The same considerations apply for Windows Direct2D and the OpenGL parts, but in Wine, Windows beat us by a factor of 2.5 in Half-Life 2, and in Trackmania Nations we beat Windows by a factor of 2.5. So the results were all over the place, which to me suggests that there are some game-specific bugs, and Windows may have the games may run into bugs on Windows as well. So there are some things we can investigate there, but GPU side configuration performance is okay as well, which I think suggests that the shader compiler is okay, the GPU is set up in a proper way, and yeah, Wine's performance problems are mostly on the CPU side, on this graphics card, but there are some things we should investigate. Just a point of warning, I tried to test a different Nvidia GPU as well and got slightly different results. So, well, not slightly, but in some games quite different. So even if it's the same driver, Wine may perform better or worse. But let's look at Nvidia's competition. A Radeon HD 5770. The system had an Intel Core i7 software side, Windows 7 and Gentoo as well, and in this case I tested the open source driver and the binary driver, and whatever driver you use, they suck. OpenGL on Windows is crappy to begin with, and both FGLRX and R600G eat way too much CPU time. And if you then go and run Direct2D applications, it's not really getting better. And at least on the CPU side, it doesn't really matter which driver you use, they both are crappy. On the GPU side, FGLRX still sucks, but it's better than R600G in this case. It seems to me that R600G runs into memory pressure, and when that happens, performance just tanks, which is mostly what you're seeing in these cases. Direct2D applications didn't run into memory pressure, so it seems that we outperform native GL, yeah?
Well, it could also be due to the shader compiler. It really doesn't
No,
optimization.
yeah, possibly, but every now and then, like in NextSuite's, no, it wasn't NextSuite's, Xonotic, its fork, the game was running at like one half frame per second, and then every now and then it jumped up to 50, and then it crawled down again. So that's probably not the shader compiler. That's probably memory pressure. I didn't really investigate it. If I investigated every slowness I found, then drivers would be perfect by now. Yeah, figuring out what the problem is a big part of the work of getting it fixed. But in this case, well, even if we fixed Wine, it would still suck because the drivers suck. And an Intel GPU, that was a small MacBook, and there is only the open source driver for that. I hope to test OS X, but I didn't get around to it. Some spoiler, it's really crappy because I started the benchmark before I went to bed, before taking the plane here. And when I got up the next morning, the benchmarks still weren't done, and I had to cancel them because, well, I had to catch the plane. And they were halfway through. On Windows, they took about 4 to 5 hours, and I interrupted them after 10 hours. And yeah, so it's crappy. And unfortunately, I have no Wine results here because the system kernel panicked after a random amount of time when running anything in Wine. I don't know what happened here. I think it's an isolated problem that probably has something to do with my EFI booting or other setup or the specific GPU. It seemed to run stable with Linux native applications, but maybe I was just lucky. And the Mesa driver, it seems to be pretty okay. It outperforms Windows. It easily outperforms the Windows driver. Although Windows, well, the other point of caution here is that many games didn't run on Windows, so the data may be crappy. Don't rely too much on it. Run your own benchmarks. Well, that's basically the hint. Don't trust my numbers. Test it yourself. And if you get different results, get in contact with me and we can figure out what's going wrong. Similar case in a GPU limited configuration. They are pretty much the same. I had to fix the scale because otherwise 0.8 would be here and the graph would look somewhat strange, but that's OpenOffice. So at least on this card, the Mesa driver seems to be just fine. Except for the crash, I didn't have any major problem with it. So, but what we see so far, Wine sucks, and I investigated one thing here, which I've suspected longer. So Windows native DirectD has the ability to move part of its CPU side processing into a different thread. Wine cannot do that. So what I did was disable all but one CPU cores in all operating systems and see what happened. So here is the mouse pointer. So basically on the Nvidia card, Wine, so that those are all DirectD applications, no OpenGL involved here. When I disabled the second GPU core in this device, Wine suddenly pulled up with Windows. I'm not quite sure how reliable the last number is, because for some reason we vastly outperformed Windows in Trackmania. There may be a bug somewhere, we don't know, so there are lots of... That's what I wanted to test the data edition, but 4 weeks wasn't enough of time for testing. So probably we just need a worker thread ourselves, probably. We won't know that until we've implemented one. But on the other hand, on AMD, even with just one GPU core, it doesn't make up for the crappy drivers. And on Intel I don't have Wine results again, but since the GPU was rather weak, and I think even the small resolution cases were mostly blocked by a graphics card, so the multi-threading doesn't matter too much. So, some conclusions. Wine's performance sucks. The rest of Wine is mostly okay because the native games, the Linux native games run as fast as their Windows counterparts in Wine. So I don't have any proof that there is a major performance problem outside Wine's DirectD code. The Nvidia driver is okay performance-wise. You can argue about it being closed source, but well, okay. The Intel driver is performance-wise okay, except for, well, the crash I had and didn't investigate. FGLRX and R600G need improvements, and the message to the MISA developers and Michael Larabel from Phoronix, don't compare R600G to FGLRX. So a dog may be able to outrun a cat, but it doesn't matter if they're competing in a dragster race. So you really want to compare R600G to Windows, because that's the Windows driver seems to run pretty okay. And yeah, I wish I had OS X results. Unfortunately, I don't. And yeah, another conclusion I took was that the worker thread really helps Windows, but it's not a magic bullet. So basically, there seem to be game-specific problems where Half-Life 2's performance sucks, but other games aren't affected. So this, yeah, and I should keep an eye on GPU side performance. I was under the assumption that all of Wine's performance problems are on the CPU side, but that's not the case. And I really have to test more cards to figure out how to find more performance problems. So just because it works on this laptop doesn't mean it works on anybody else's Nvidia card or whatever. So even between the same driver there are differences. And how can we go forward? Well, it will still require a lot of work. But at least we can focus the Wine work on the Wine D3D module and don't have to jump around or everywhere in the Wine code. We want a worker thread, I'm working on that. Well, we also want a Direct3D implementation, Unreal is working on that, but both of things will take a while. And there seem to be many game-specific problems, especially on the GPU side. And it will be a work of hunting down one problem after another and fixing one problem after another over a long time. So, okay, I've written a thesis lately, so this slide has to go in. Basically, don't trust my numbers, as I said. There may be game-specific bugs. Sometimes a setting may not be correctly controlled. When I looked at the numbers in the plane, I didn't quite trust some of them and wanted to rerun some benchmarks, but you can't do that in an airplane. At least not when you don't have the computer with you. And I calculated the relative numbers and the aggregates manually, so I just may have to mistype something. So basically, run your own tests if you want to know for sure. If you want to look at my raw data, I have some URLs here, and thanks to openbenchmarking.org for providing the help with automating that with the Phoronix test suite. And yeah, basically that's it from my part. Any questions? Yeah?
What about the strict draw ordering? For example, I was playing Assassin's Creed.
Yes?
So with the open source driver, the Radon, it draws fine.
Mm-hmm.
The binary driver, you get corruption
Oh,
over, and you have to enable this.
The strict draw ordering, which enables draw ordering across contexts. We want a worker thread for that. So we can sync. Basically, if you have two context renderings to the same buffer, then the commands arrive in any order. The strict draw ordering enables flushes every time we draw something, which kills performance. If we have a worker thread, we can synchronize these things much cheaper by properly locking our list of commands. Yeah, it's work in progress. And hopefully it will help there.
Just had a comment on the Intel side. So I'm not surprised by the 965 numbers. Those are pretty terrible, which is pretty much what that chipset was.
Yeah. I don't have a newer one, unfortunately, but I know about that newer ones are better.
Yeah, the Sandy Bridge is really the first one that can play modern games reasonably. I played through Dragon Age and Mass Effect on that. It's playable. It's not as good as a discrete mobile part from Nvidia, but I think that's HD 4000 graphics or something. That's pretty decent.
Yeah.
And the Ivory Bridge stuff we're shipping now is actually pretty good.
Well, every now and then the small i965 surprises me. Like, it runs Half-Life 2 pretty well. It runs Trackmania pretty well. It does not run Unreal Tournament 2004, which is, well, a much simpler game compared to the other two. But
is that bugs on the Wine side or on the side?
It happens on Windows as well, so I think it's just a chip. Maybe the game is doing something the chip doesn't like. I don't know. I didn't have time to investigate that more closely. But yeah, I'd really love to have more cards, but I have like 10 computers at home already. I should rent an office and put a server farm there or something.
I wish Intel sold discrete cards.
Yeah, sometimes me too. Yes?
Is there any hope to see DirectX 11 support in Wine in foreseeable future?
You have to ask Henri.
How long do you count as foreseeable future?
Like in this year and next year? Okay.
So
Probably.
probably.
If somebody helps, it gets faster.
Yes?
I seem to remember that there was some talk about creating a state tracker for Gallium or DirectX and things like that. Would that solve some of these issues, maybe?
I don't think so. I haven't looked at the code. There was some legal issues about whoever wrote this state tracker looking at using some Microsoft header files, internal header files from the driver development kit. So I kept away from the code.
So I think that code got, the guy who had worked on that wandered off from the project and it just bit rotted for a year or two, and I think it actually got deleted.
Can you work on it at one time? Because
You need time to work, but then in
But
time
he
on
also
it and
doesn't intend to work on
I
this
don't think
anymore.
it actually got
But
I don't think it builds anymore.
OpenGL is not a bad interface to implement DirectX on top, and we probably wouldn't spend any time on the Gallium tracker anyway because we run on OS X, we run on the binary drivers. You can even use our DirectX implementation on Windows. Sometimes it fixes problems with the Intel driver there.
Well, and the other issue with using that is Gallium doesn't really have stable external.
Yes.
So we'd either have to do half of the work in the basic state tracker or deliver possibly.
So it would be a nice thing to hack on, but if the day had 48 hours, then yeah, I probably would like to hack on this, but it doesn't. Anything else?
There's a lot of people in this room paying attention to you right now. Do you need anything?
World peace.
Probably help tracking performance on other cards. I have nightly benchmarks running on 3 machines at home, but it's just covering 3 GPUs. So if you have a computer with Linux installed and a Windows installation as well to compare to, I would appreciate if you got in contact with me. I can help you set up the benchmarks so we can keep track of more GPUs.
You must have an extra Ivy Bridge, right?
I'm sure we can find some stuff.
You want older cards? For example, I have a 4070.
I have plenty of older cards, and well, actually one of my common fun projects is to hack on my old Radeon 9000 with the ATI fragment shader extension. It's a really crappy API, but it's fun to work with, so every now and then I hack on that. But
Are there some benchmarking guidelines, so that we can actually benchmark the right things? If we want to do CPU limited or GPU limited.
well, you really have to. Well, it's really have to look at every specific games. So basically, for CPU limit, my rule of thumb is if you increase the resolution and add in anti-aliasing, you get GPU limited. Well, that's the thing on the Intel card. I think it was limited in the Vertex pipeline on the GPU. So if I increased the resolution, the performance didn't drop as much as I expected. But if I disabled a CPU core and got disabled Windows multithreading, I still got the same performance. So it was probably GPU limited on the Vertex pipeline.
So on that
It's difficult.
Yeah, on that particular chip, because it was the first, completely new design, and they had no kind of performance data or anything about it. The Vertex pipeline was awful, and some people in the Windows team had done some experiments with just running the Vertex shaders on the CPU instead of on the GPU, And in a bunch of apps, that was fast.
Yeah. So I think it's the first Intel GPU that had hardware vertex processing.
Yep.
But yeah, and basically doing proper benchmarks is pretty tricky, and whatever setup you use, you can find some argument to say why the benchmark is bad. There is no good benchmark.
So I think a good idea would to have the web page how to set up the test, because hopefully many people will spend some time to run the test, and then it would be the easiest for them, I think, so when they have a page to read.
The problem with that is that for a bunch of my benchmarks, you actually have to own the game. Like Unreal Tournament 2004, I didn't get the demo running for benchmarking, so you have to own the full game with a CD key, which makes, I can't completely automate them, unfortunately. Well, I can automate, running them is automated, but installing them isn't. And in general, if you want to help out with Direct-to-G development on Wine, if you have a game that doesn't run and you know your way around C code or OpenGL, try to fix that game, get in contact with us, we can help you isolate problems. But I think Mesa needs developers as well, so you're probably helping me quite as well if you just help improve the drivers. All right, so any more questions? Yes?
What about the Southern Islands chipsets, the new ones?
I don't have a GPU with that, unfortunately.
Yeah, me neither, but the 3D support is pretty new. So
Yeah, so I hear that it's crappy, at least in the open source driver. Maybe not. I don't know about
It's basically
FOSSDEM.
easy for Southern Islands on Mesa.
I think it has, but it's just slow.
Just enough to run it.
Like when a GeForce 8 card shipped, Nvidia shipped an old driver version that had GeForce 8 support hacked in, and the binary driver, and the performance was worse than a GeForce 6 until they shipped the 100 series driver. So sometimes on Linux, an older card can give you better performance than a newer card.
especially on
Yeah, and yeah, I would have liked to test the driver as well, but it doesn't work on my MacBook because I don't know why. Probably because I'm booting from EFI.
We don't recloud the cloud, so either you have good clouds which are close to the normal operating clouds, or you get some very low clouds like the tenth of the memory.
Oh,
So
so you cannot set the clock yet.
yes and no. It's very experimental.
I see.
We've been working on that for years. It's getting low.
Yeah, I'm somewhat interested in the embedded drivers as well, but this doesn't run any Windows applications anyway because the CPU is different, so yeah, I don't know. Oh, and well, if you may want to write some good games with proper graphics, because especially OpenGL games, well, that's a hard thing to do, but there are no good Linux benchmarks. There is Unigine, and then there are like 20 games which are based on Quake 3 and have some shadows and bump mapping hacked in. And
my issue with Mali as well. There's
yes,
no good benchmark.
there are no good benchmarks. You can run 20 benchmarks with Quake 3 and you get the same result essentially.
But Valve is going to fix all that, right?
Well, I actually tested the Team Fortress 2 native port. On this machine, Wine outperforms the native port, and Windows kills both of them. And on my other machine, which had the one with the Radeon GPU, but with an with an Nvidia GeForce GTX, I think 460, Windows and Linux native are equally fast, and Wine is like 30% behind. So, but Valve internally also maps Direct-to-D to OpenGL. They take some shortcuts, probably don't care about old cards, but it's since that the Linux Team Fortress 2 port can compete with the Windows version, shows that OpenGL is not a bad API to base a D2D implementation on.
So they're actually internally using OpenGL 3.0. They're using a handful of features that.
Yeah. So Wine still cares about cards that never supported shaders, that don't support frame buff objects. So I think
There are actually some frequental skate attributes.
yeah, we can use them, but we have lots of
Really doesn't run.
our legacy codes may sometimes have some performance impact. Maybe not. Will probably know more once we have a worker thread. But it's in some cases I fixed some problems with the legacy code. Some problems may still remain. All right, so let's wrap this up. Are there still more questions? Okay.
It could probably take general D3D questions.
Yeah, general wine, general D3D questions or discussions. Why isn't my game up?
Because I don't know its name.
Guild Wars 2.
Well, Guild Wars 2 needs a worker thread, I think.
Anything else? Thank you.
No, thanks for showing up.